So now let's deal with the multiple choice questionnaire. First question is about the stress tensor and why it should be symmetric and not asymmetric. So the stress tensor, is symmetric because an asymmetric one would cause problem. Of course, in that case, the angular acceleration in a small region would diverge. To explain it mathematically, we can calculate the angular acceleration theta by the division of the torque tau on the moment of inertia I. So theta is equal to tau divided by I, which is proportional to, proportional with that symbol, to the stress, the sigma yx minus the sigma xy divided by rho L squared. And you can see that when L tends to 0, the angular acceleration diverges, which is impossible physically. You can see further details in the booklet at part 4.2.6 if Mr. McNamara does not change his format. Now, for the next question, we can say that when we move a solid, it doesn't disintegrate on its own, so the solid can support small perturbations. This means that when an atom is pushed, a force pulls it back to its equilibrium. We can assimilate this to a spring with this equation, with A the acceleration, M the mass, K the constant of the spring, and UK the vector, which UK which will lead the vector. You can also see further details in the booklet at part 2.3.2. Now, for the third question, we assume that we have a rectangle of a specific length, height, and of course depth, like that. And it is translated without deformation. So we just put the sample over there, for example. What can we say about the strain tensor? Well, you first have to remember that the strain, epsilon, is equal to delta L divided by L. This is a tool which can brings you some information about the deformation of a solid. So if the solid is only translated, there is simply no deformation. So the only thing which is right on the choices is sigma xx is equal to 0, because there is only a translation and no deformation. Now, for the fourth question, you have this picture, and in the booklet we use that picture to have a specific conclusion. We showed that the total force inside the cylinder is equal to 0. So the forces on opposite faces of the cylinder compensate each other. So if we have, if we cut the cylinder perpendicular, like this cut here, there must be a force that acts to compensate the forces on each side of it, like a fictive one here. So there must be a force, so a stress inside the cylinder. Now we are going to answer the other questions. So what is the SI units of sigma ij? This is the stress tensor, and as we said before, this is something related to a pressure, so it's in Pascal, like this. For the displacement xi, it's in meter because we move a sample. And for the SI units of epsilon ij, this is the strain, and as I said here, this is a length divided by another length, so this is dimensionless. This is equal to 1, or if you want, no dimension. And for the final question, what can we say about the properties of the orthogonal matrix? This is something to learn, simply that you have a matrix times its transposal equal to, sorry, this is not 1, this is the identity matrix. So of course it depends of the dimension, but they have to be a square matrix.